You know, our sun, the star at the center of our solar system, it's been holding out on us. It's been hiding a pretty big secret. But a brand new paper just out in January 2026 has finally cracked the case, revealing that our star doesn't just have one engine, it has two. Let's get into it. For years, solar physicists have been scratching their heads over the sun's, well, its split personality. When they look at sunspots, which are basically windows into the sun's powerful magnetic field, they see two totally different kinds. Some are simple, calm, well-behaved. But others, they're complex, they're chaotic, and they are incredibly powerful. So what's going on here? And look, this wasn't just some random thing they noticed. It was a really deep, fundamental mystery about how our star works. But now, a couple of researchers, Anastasia Zhukova and Valentina Abramenko, have found a clue that honestly changes everything. Okay, so to really get to the bottom of this stellar puzzle, we've got to understand the two different faces the sun shows us. For the sake of this, let's call them the rule followers and the rebels. So on one hand, you've got the rule followers. These are your classic by-the-book sunspots. They follow all the established laws of solar physics, like Hale's polarity law, which dictates how their magnetic field should be oriented. But then you have the rebels. These guys are messy. They're complicated, and they seem to love breaking those very same rules, which is what makes them such an interesting mystery. The real key to figuring out these rebels was to stop just lumping all sunspots into one big category. Researchers over at the Crimean Astrophysical Observatory realized they needed a whole new way to look at the sun, a new lens to see it more clearly. And what they came up with is called the magneto-morphological classification. Yeah, it's a mouthful, so we'll just call it MMC. Instead of just looking at things like size, the MMC sorts sunspots based on their deep magnetic structure and, crucially, whether or not they follow the rules. And this new approach, it was a complete game changer. So, first up in this new system is Class A. These are our rule followers. They are the regular, predictable regions that behave exactly like all our models of the sun say they should. Think of them as the sun's steady, reliable, everyday output. And then you have Class B, the rebels. Oh yeah, these are the wild ones, the irregulars, the rule breakers. They show up with the wrong magnetic polarity, they're tilted all wrong, and they often form these huge, complex magnetic messes. These were the big clue that something else, something much more chaotic, was happening under the surface. Now, when the researchers took this new system and classified more than 3,000 active regions, check this out. The rebels weren't some tiny fraction. They make up nearly a third of all sunspots. So this isn't some rare exception to the rule. It's a huge part of how the sun actually works. So now, with this powerful new classification tool in hand, the scientists went on a deep dive. They took 25 years of solar data, from 1996 all the way to 2021, covering 2 entire solar cycles, and they started following the magnetic trail to see where it would lead. And what they found, well, it was absolutely astonishing. Once they separated the two groups and plotted their magnetic power over time, the rule followers and the rebels told 2 completely different stories. It was almost like they were being generated by 2 different stars. The power from the regular A-class sunspots looked just like you'd expect, a nice, smooth, steady wave, rising and falling predictably with the solar cycle. But the irregular B-class sunspots? Whoa! Their power was a series of jagged, violent, powerful spikes. It was totally wild and completely unpredictable. And here's the kicker. These rebels weren't just weirdly shaped, they were magnetically supercharged. We're talking about the most complex rebel groups having a magnetic flux up to 4 times greater than the regular ones. They were packing a serious punch. So, what does it all mean? You've got this smooth, predictable signal and this jagged, powerful one, both happening at the same time on the same star. This observation led the researchers to a truly groundbreaking conclusion about what's going on inside the sun. These 2 totally different magnetic signatures, it turns out, weren't a fluke. They were fingerprints. The fingerprints of 2 different engines, or what scientists call dynamos, operating simultaneously deep inside the sun. Okay, think of it like this. The first engine is the global dynamo. It's like a big, smoothly running factory on an assembly line, just steadily churning out those regular, Class A, rule-following sunspots. But right alongside it, you've got the turbulent dynamo. This one's more like a chaotic experimental workshop, where turbulence just grabs and twists magnetic fields into knots, creating those complex, powerful, and unpredictable Class B rebels. And let me be clear, this isn't just some cool new theory. As the researchers state right in their paper, this is the first observational evidence that these two processes are happening at the same time. They actually managed to separate the two signals and see both engines at work. So we've solved a fundamental mystery about our sun. That's incredible. But why should we here on Earth care? Well, it turns out the sun's rebels are the ones we really, really need to be watching. See, it all connects together beautifully. The turbulent engine is what creates the B-class rebels. That chaotic process is what makes them so magnetically huge and complex. And it's exactly those large, complex regions that are the main source for the most powerful solar flares and storms that can have a major impact on us here on Earth. By finally identifying the fingerprint of this turbulent engine, we're not just observing the sun's weather anymore, we're starting to understand the fundamental machine that creates it. And that is a giant leap forward in our ability to forecast the dangerous space weather that can disrupt satellites, our power grids, and communications. This discovery just blows the doors wide open. For the first time, we can actually see the two engines of our sun humming along. And it leaves us with this incredible question. Now that we can finally identify the rebels and understand where they come from, are we on the verge of being able to predict the sun's most powerful and dangerous outbursts?